Diary. Hello, it is February 2024 and today we are doing another inventory test of the INV033 card 33 OCTART. So, what are we going to do? We're going to show you the results first to show it is working, and then we're going to show you why it's working. So here you have one screen, and on this screen we're on command number 25, and if I do the who command, you will see that it is working. We've got two terminals connected. We've got effectively the console, which is also OTTY1, and we've also got OTTY2. Now, how is all of this working? Because here is the other terminal here, which is the console itself, and here is the other command. So I've got on this host computer, I've got two USB cables going into serial ports. First port is going to the console, which is driven off the floppy disk controller, and the second port is one of 8 possible ports driven off the OCTART. So you can see that everything is working. We've effectively got 2 users logged onto the system. Right, so put that screen away, and I'm going to show you how it's working. So, first thing to do is to boot the operating system. So we're going to do boot, we get focus. We're going to do a boot of /Cromemco to show you the boot of the operating system. Effectively a reboot, because we were already booted. So first we're doing a memory test by 16K blocks, up to that colossal 4 megabytes of memory that I mentioned in my last OCTART testing video. We're booting the operating system. It's running on a XXU CPU, which is the top of the line CPU from Cromemco. Excuse me. It's also got the drivers for STDC hard drive controller, remote Z80 command support, and the OCTART 8-port serial interface. So we've booted up. The time date is wrong, but I can't change it past 2023. That will be a completely different video. We are working. So again, if I go to this screen, hit enter, nothing happens, and that's because well noticed, if we type out the TTYs file, you see on the left hand side we've got run levels. So we've got run level 1, which is what it's currently set to, and if I set the computer to run level 2, it says in the terminals file etc TTYs to run not just the console, but also OTTY1 and OTTY2. So we're going to do that by saying init space 2. And now, as if by magic on the second screen, this has just come along. This prompt has just been shown, because it's set to auto login. So the syntax is here, which says terminal init level 2, the baud rate should be 9600. We're on OTTY1, the terminal type is M100, which is effectively VT100, and please log in with the user system. So it's done all of that. So this is the system log done. Do who command, and you'll see we're now December the 12th, 2023 at that time. Okay, so it's a bogus time, but that's the best we're going to get to. So how is it working in more detail? Not just the TTYs file that tells the computer to start those terminal processes. If we, by the way, if we do something like a PS, here we do a PS -EF, no, PS -AL. So you can see it started a shell process for these other terminals. So all is working fine. So what else is there to show you? Well, the reason that this is all working is because we have generated a particular operating system. So in the root directory of the computer is a file called cromemco.sys. It has to be named cromemco.sys, otherwise the bootloader won't find it. And it's a size of 114908 bytes. And I'm in the gen directory, and there's a configuration file for the operating system called sysgen. Can actually be called anything you like. I've called it sysgen with a date on it. So with the Cromemco operating system, a star does not go through a dot. So I had to put 2 stars, and then that goes through a dot. So there's the file, 2024.0205.sysdef. So we're going to have a look at that file. So CE editor, 2024.0205.sysdef. There's no command completion, you have to type the full name in. So we're going into the CE screen editor. You can see that we can have up to 16 256K cards, and then you've got a list of character and block devices. So we've actually got the character devices. Now we could have a terminal here at CDEV13. That's the old terminal driver, but that's not actually used anymore. Let's try and scroll up so you can see all the devices. So there are all the devices that we've actually got defined. Instead of using the OCTART driver, we're using the more up-to-date OTTY driver. And that's saying, look for the OCTART terminal and look for it at address 1. And address 1 relates to an address that we're going to see later. So let's try and find OTTY. It's there. Next occurrence is there. Next occurrence is... So here's the driver definition. So we're saying, we typed in OTTY space 1. What we're actually saying, excuse me, is to ask for the OTTY OCTART to be defined at base hex address CE, Charlie Echo. So what this means is you've got to take out the OCTART card physically and change the dip switches to have that base address. And using that base address, the system, which is the 68020 system, can send commands and data to the OCTART, whose data port, if you like, starts at hex CE. So, quit out of that. So that is it really. You've seen that we've got 2 terminals working. We've configured the operating system with the specific version of Cromemco, and that version is sitting now in the root directory of this hard drive, so that when the floppy disk monitor starts up, we ask it where it wants to boot to, and we are going to say the 4th partition, which is where the Cromemco 172 operating system lives. It's going to load that, and then it's going to look at the definitions of the block and character devices. And it says, okay, I see an 8-port serial card starting at hex CE. And that is exactly equal to the hex address that I've configured for the serial card, and therefore it all works well. That's it, diary. I hope that's all logical and sound and working. Thanks for watching.